Okay, so start off with 8. The maximum mass that can be hung vertically. So we're going to hang a mass vertically. It's 10 kilograms with a string without breaking. So look at what that says about that. That means that if this is, means that would be the force max in the string, right? And that would be equal to, right before it breaks, to the weight. The weight of a 10 kilogram object is 100 newtons. So therefore, F max equals 100 newtons. All right. Let's see. Now we have a length of string that is 2 meters. It's used to rotate. Okay, we're going in a circle. A 5 kilogram object. So this is going to be your R. Okay, and then your mass over here is 0.5 kilograms. All right, we're going to rotate that in a circle, and it wants to see, let's see, we've got a frictionless table, and it's horizontal, so this is like you're looking at the tabletop. All right, so it wants to know the maximum speed the mass can attain. That should tell you right there you're dealing with a centripetal force problem. So you're going to have mass times your centripetal acceleration, which if you recall is your vulture squared over your dead rat, and it's going to be equal to your maximum force. Okay, so look, let's just go, let's get this V isolated. So let's go R over M, and then we're going to do the square root. So you've got V equals square root of F max R over M. So it's going to be 100 times 2, and your mass is 1/2 kilograms. So I'm just going to flip that over. That's going to be another 2. So we're going to end up with the square root of 400. Square root of 4 is 2. Square root of 100 is 10. So that's going to give you 20. D is your answer. All right, an object moving on a horizontal frictionless surface. It's frictionless. Okay, I'm going to just say it's moving that way. Frictionless means your net force is 0 for your system. Okay, has a glancing collision with another object that's not moving. Just go with V equals 0 because it's not moving. Glancing, that's weird. That means barely grazes, barely touches. It's really an ambiguous word. We don't know what it means. Another object that's at rest. In this case, which of the following is true about momentum and kinetic energy? Well, since this is the case, since your system's net force is 0, you know that momentum's going to be conserved for the system. Kinetic energy, it depends on if they stick. If they don't stick, I mean, you know, if you have, or I should say, if you have an elastic or an inelastic collision, there's just no way of knowing that. So the only thing we know for sure is momentum is going to be conserved. So A says momentum is always conserved. Okay, good. And kinetic energy might be conserved. Possibility on this one. Kinetic energy is always conserved. Nope. Momentum is always conserved, possibly, and kinetic energy is never conserved. Well, we just can't know enough. We don't know enough to say never. We don't know what kind of collision it is. Both momentum and kinetic energy are always conserved. Nope. We don't know what kind of collision it is. Neither momentum nor kinetic energy, well, we know that's not true because we know momentum is conserved, so therefore it has to be A. Now, there are some questions that take a ridiculously long time to explain. 10 is one of them. The answer, by the way, is B. Work the units out. It's between these two. I'll explain what the 2 is later. But yeah, this one, I kept trying to do it. It's going to take me like forever to explain that one. All right, moving on. 11. I messed this one up earlier because I can't add. 3 blocks, A, B, and C, of masses 1, 2, and 3 kilograms respectively, 1, 2, 3, are on a frictionless surface, so no friction. Okay. As indicated by the figure above, what force F has to be applied to block C to accelerate the 3 blocks 2 meters per second? Well, this is just one big thing that is 3 plus 2 plus 1, as I found out earlier, is 6 kilograms. That's the mass of your system. Okay, so if you want your mass times your acceleration to equal, well here, mass times acceleration is going to equal your force, so therefore that. Oh, we just want to know what force has to be applied. Okay, so that'd be like 6 for your mass, and your acceleration times 2, that's 12. Okay, so the answer to this guy is E. All right. Oh, electrical. Electrical power provides 50 watts of mechanical power. So power equals, I'm going to put a ½ watt here. That's usually easier. That shouldn't be capitalized, but whatever. Okay, how much time will it take the motor to lift 1 kilogram, 0.1 kilogram of mass? So 1/10 of a kilogram. However you want to do that's fine. That just is easier for me. You can use your calculator. At a constant speed, okay? So that means acceleration equals 0 from the floor to a shelf 2 meters above the floor. So height is equal to 2 meters. All right, so here is what happens. So power is change in energy. And we know it's not kinetic energy, so I'm thinking it's change in potential energy over change in time. Therefore, time equals, it's going to be that times your potential energy due to gravity. Ah, it spells pug. All right, so therefore time is going to be 1/2. Remember, this is U is mgh. Is going to be 1/10. That's a half watt. That is 1/10 of your mass. That is 10 times your acceleration due to gravity. And that is 2 times your height. Okay. Guess that one is going to be, I did that wrong. Hang on.